Okay, today we're going to learn about how to draw sine and cosine graphs. If we have sine or cosine graph equation that looks like this, so y equals, we'll say y equals, to a sine of b x takes c plus d, the values here tell us very different things. And the same logic will also apply if we had a cos of b x takes c plus d. Okay, so for sine and cos, the rules are pretty much the exact same. So if we have two equations like this, we can work out a few things. The first thing we can work out is what is the amplitude of our graph. And the amplitude will tell us how high or how low the graph will go. And the amplitude of a sine or cos graph is simply equal to the value of a. The amplitude is equal to the value of a. And just to reiterate what the amplitude means, the amplitude tells us how high and how low our sine graphs go. So in this case, we can say if the maximum and minimum is both 1 and -1, the amplitude for this graph is equal to 1. However, if we had a graph that looked like this, we had a graph that went just a little bit higher and a little bit lower like this, and the maximum was 2 and the minimum was -2, then the amplitude for this graph would equal to 2. And that's what the amplitude here means. Then we can describe what's known as the period of our graph. And to work out the period of any graph, it is simply the same as 2 pi divided by the value of b. And this is if you're in radians, but the same logic applies if you're in degrees. It's just 360 degrees divided by the value of b. And what the period describes is how often your graph will repeat itself. So let's suppose this is a sine graph like this. Okay, so we can see we have 1 unit of our sine graph from here to here, and then it'll continue repeating itself like this. So this is our second unit, this is our third unit, and so on, and so on, and so on. Now if I compare this with another graph that were to look like this, okay, so if it looks like this, you can see the amplitude for both of these graphs is the exact same. See, it keeps going to the same height as well as the height below it, so it goes same maximum and same minimum values. However, it keeps repeating itself a lot more frequently, and obviously this isn't the best graph, but it keeps repeating itself a lot more frequently. So that means the period of this graph, the orange graph, is a lot smaller or less than the value for the period of the purple graph. And to work out the period, we can just use this formula here. The next thing we're going to work out is the following. We're going to work out what are the values, what are the equations for our maximum value, our minimum value, and our mean value for the graph. To work out the maximum value of our graph, wherever the height or the peaks of all our graphs are, so sine graph looks like this, it'll keep oscillating. The maximum height it will reach is the same as just d plus a, so d plus a. The minimum is equal to d minus a, and then the mean is simply equal to the value of d. And with these 5 pieces of information, we're going to be able to draw any sine or cos graph. So let's have a look at how to draw this equation here. How do we draw y equals to 3 sine of 4x? The first thing we're going to do is to just sketch our max line, our mean line, and our min line. In this case, we can say that the value of a, b, and c, and d are the following. A is equal to 3, b is equal to 4, c is equal to 0, and d is equal to 0 as well. So now that we have these 4 pieces of information, let's work out the max and min of our graph. The max line is simply equal to the value of d plus a, which in this case is just 0 plus 3, which is equal to 3. The mean line is equal to the value of d, which is just 0. And the minimum most value of our graph is simply equal to 0 minus 3, which is minus 3. So I'm just going to sketch these 3 pieces of information on my graph above here. So if I were to sketch that out, it would look like this. So at minus 3 we have a minimum, and at positive 3 we have a maximum, and then at 0 we have our mean. Okay, so this information here is just our max, min, and mean lines. The next thing we need to recognize is, where does sine start? Does the sine graph start at the origin on the mean line, or does it start at the maximum and minimum lines? And the easy way we can figure this out is by simply looking at the exact values for sine and cos. If we draw out the exact values for the sine and cosine graphs, so we can have the sine here and the cosine here, and we can draw it out for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. If we were to compare the values, we would know that sine of 0 starts at 0 and ends at 1, but the cos of 0 starts at 1 and then ends at 0. So we can see here that the sine graph will start at the mean line and it will go towards its maximum, whereas the cos graph will start at the maximum and approach the mean line, for which then it will go to -1, and then the sine graph will go back to 0. So because we have a sine graph starting at 0 and ending at 1, we would start at 0 over here. Okay, and we know we start at 0, 0 because there is no horizontal or vertical translation going on in our graph here. So we can confidently say that on our graph, we start at this value here, at 0, 0. The next thing we're going to work out is, what is the period of our graph? Okay, and to work out the period, it's very straightforward. Okay, the period, which is also given by the capital letter T, okay, that is simply just equal to 2 pi divided by the value of b. Because our axis here is in degrees, we can also say it's 360 divided by b. So that means 360 divided by the value of b, which in this case is just 4. The period is 90 degrees. So that means our graph will look something like this. It'll repeat itself every 90 degrees. I'll draw it better. It'll repeat itself every 90 degrees like this. Okay, so that's what this 90 degree talks about. Just for the purposes of drawing our graph, just for making it nice and easy for ourselves, I'm also going to work out, what is the period divided by 4? What is a quarter of my period? Okay, so a quarter of my period is the same as 90 divided by 4. And 90 divided by 4 is simply just 23 degrees. Sorry, not 23 degrees. It's equal to 22.5 degrees. So now that we have the period divided by 4 is 22.4 degrees, 5 degrees, okay, we can actually draw it on our graph like following, okay? I'm going to separate. I know that one period of my graph is over here. I know that one period is every 90 degrees. So I'll draw a vertical line at 90 degrees. And I'm going to quarter my graph. Okay, I'm going to quarter it so that I have a line at every quarter of 90 degrees. So we have one at 45 degrees, and then we will have one that's half of this, which is 22.5. We just worked that out. So 22.5 is roughly here, not too exact. And then we also have a line over here. Okay, so we know that our graph starts here. It starts at the origin, and we also know that it ends at the origin at 90 degrees because it will repeat itself every 90 degrees. So here's what we can do. Okay, we know our graph should look something like this. Okay, it should go up first, then go back down, then go down even more, then go back up. And the purposes of these vertical and horizontal lines is to tell us exactly where to put those points. So if you have a look here, we can say that the graph will first go up to here, then down to here, then down to here, then up to here. So it'll oscillate between max, mean, min, max, mean, min, and etc. Okay, and now we're just going to draw those points just to make our lives a little simple. So a point here, point here, point here, and a point here. Okay, and just to make our graph less ugly, I'm just going to get rid of my max line, my mean line, and my min line. So let me just draw it out properly. Okay, so now we have the following points, and we can just connect the points now. We can just connect them up to make it look a little bit more visually aesthetic. Okay, like something like this. And that would be how you draw the graph of y equals to 3 sine 4x. So let me actually just connect the points just so we can have it properly. So we go up like this to the maximum, then we come back down to the mean line, then we go to the minimum, and then we come back up to the mean line. Okay, and this is one period of our sine graph, and this will repeat itself every 90 degrees. And using this information, that's how you graph the graph of y equals 3 sine 4x. Now let's have a look at this graph here. We have y equals to 2 cos of x plus pi on 6. And just remember, if sine starts at the mean line, then cos will start at either the maximum or the minimum. We have to check based on the sign of the amplitude. So first, let's work out the 5 information that we need. We need the amplitude, which is the value of a, and the value of a here is just 2. So it is just 2. The period, that is equal to 2 pi. We're doing 2 pi in this case because our axis is given in pi, in radians, divided by the value of b. And 2 pi divided by the value of b, which in this case is the coefficient of x. And the coefficient of x is just 1. So that means it's 2 pi divided by 1, or simply just 2 pi. Okay, that is our period. And then we're going to work out the values for our maximum, our mean, and our minimums. Okay, so the maximum is equal to the value of d plus a, which in this case will be 1 plus 2, which is 3. The mean is equal to the value of d, which is 1. And min is equal to the value of 1 minus 2, which is minus 1. Okay, so just for my benefit, just so it makes my life easier, I'm going to draw those minimums and maximums and mean lines on my graph right now. So we have maximum at 3. Just going to make it nice. And then we have our minimum at -1. And then we have our mean line at y equals 1, like such. The next thing we're going to work out is the graphing of the first initial point. Okay, if it's a positive value for a, if our a value is positive, that means we should naturally start at the max line. Okay, so rather than sine starting at the mean line and going like this, cos will normally start like this. Okay, it's only difference between sine and cos is where it starts. Otherwise, the graph will generally look the same. So normally for cos x, we would start over here. Okay, but we want to work out what is the x value for when the y value equals to 3, because we have a phase shift, we have a translation in the x-axis. And if we see plus pi on 6 here, we can simply say that that is the same as a translation to the left by pi on 6 units. Okay, so I'm going to simply shift this maximum point over here by pi on 6, and pi on 6 is the same as 30 degrees. So that would be roughly over here. So whatever that x value is, I'm going to put my green point over there. Okay, so now we need to recognize that because our period is 2 pi, or 360 degrees, we should be repeating again after 360 degrees. So if I added 2 pi to this minus pi on 6, what we should have is 11 pi on 6. And 11 pi on 6 is 330 degrees. Which would be roughly, if I can find it, 330 degrees, that'll be roughly over here. Okay, not too exact, but it'll be roughly over there. Okay, so I'm just going to draw a point over here to symbolize that I end over here, but then I start over here. Okay, so now let's work out the quartering. We worked out the period is 2 pi, but we know that the period divided by 4 is what we're really after when we're graphing. So that would be 2 pi over 4, which is just equal to pi on 2 radians. So now let us graph a vertical line every pi on 2 radians. Okay, so in this case, this is minus pi on 6. I'll graph this point as well just to make life easy. This point here is minus pi on 6. This point here is 11 pi on 6. Now we need to add pi on 2 to this vertical line here, and adding pi on 2 is the same as adding 3 pi on 6. So let us now do that. We're going to draw a graph every 3 pi on 6. So plus 3 pi on 6 to this will be the same as 2 pi on 6 or pi on 3, which is over here roughly. Okay, that's roughly 60 degrees. Now we can do the same thing. So we do pi on 3 plus 3 pi on 6, and that would be the same as plus 2 pi on 6. So 2 pi on 6 plus 3 pi on 6 is 5 pi on 6, and that would be the same as 150 degrees. And 150 degrees will be roughly situated here. It's obviously not too accurate. It's just a rough sketch for this one. And then lastly, 5 pi on 6 plus 3 pi on 6. That's the same as 8 pi on 6, or simply just 4 pi over 3. And 4 pi over 3 would be the same as 240 degrees. And 240 degrees will be roughly over here. So there you go. We have just devised our entire graph in quarters, and we know that we oscillate between maximum to mean to max, like that. Okay, and we've just repeated a cycle. So this is one period of our cos graph, and it would simply keep repeating itself again and again and again. So I'm just going to make a little X's to show that I start over here. Then because we're at the max line, we jump down to the min line over here where we intersect. Then we jump down one more line till we intersect with another vertical line. Then we go back up over here. Then we go back up over here. Okay, so I'm just going to cross the points where I'm going to mark, just so my graph is a little easier to visualize. There you go. So now we have these 5 points here. Let us draw the graph so it's a little bit nicer. So we can say the graph will go like this to this point. Then from here to this point, it will look like this. Then to the next X over here. And then finally, one period is complete when we end up at 11 pi on 6. Okay, and just tidying it up, this is what our graph will look like for y equals to 2 cos of x plus pi on 6 plus 1. Okay, so this is one period, and the graph will, you can keep going left or you can keep going right. Sorry, you can keep going right or you can keep going left by simply applying the same vertical line and horizontal line technique. Okay, this is our next one. We're going to do the exact same thing. We're going to graph this graph here, which is y equals minus sine of x take pi on 3 minus away 2. So again, we need the 5 pieces of information. We need the amplitude, the period, which in this case I'll just say is capital T. We need the max, the mean, and the min. Okay, so let's work each of these out. The amplitude is simply just the value of A. In this case, A is minus 1, but for the amplitude, we don't really care about the sign, we just care about the actual size of the amplitude. So you can say it's the absolute value of A, okay, which is really just the same as 1. The amplitude is just 1. Then we can ask, what is our period? Our period is simply the same as 2 pi divided by the value of b, and because we know the value of b is just the coefficient of x, which in this case is 1, 2 pi divided by 1 is just 2 pi. And the maximum, we can work that out by doing the value of d plus a, so minus 2 plus minus 1 is minus 3, the value of the mean is minus 2, and the value of the min is simply minus 2 minus minus 1, which is just minus 1. And what you would notice here is the maximum value and the minimum values, they're actually swapped. And the reason this has happened is because our amplitude here is actually negative in this case. So when we have a situation like this, just swap these values around here, okay? It doesn't have to be too complicated. So now your maximum value actually represents what your maximum value should be, and your minimum value actually represents what your minimum value should be. So now that we have this, let us now do the period divided by 4. And the period divided by 4 is simply just pi over 2. So now let's get graphing. Let us now do our max lines, our min lines, and our mean lines. So our maximum is at minus 1. Our mean line is at minus 2. And our min line is at minus 3. Like this. Next thing we're going to do is we're going to start with our start point. Again, we know that sine will never start at the maximum and the minimum lines. They will always start at its mean line, and it will oscillate either like this or it'll oscillate like this. Okay, so let us now work out where we start. And another way we can work out what the start point is we can simply just let the y value equal to the y value of our mean line. So in this case, let's let y equal to -2 and just solve for this equation. Okay, let's now solve for this equation. We can add 2 to both sides, and if we add 2 to both sides, we get 0 equals to minus sine of x take pi on 3. We can also times both sides by -1, in which case this negative will go away. And so now we can solve for this value here. We know that sine of 0 degrees is the same as 0. Okay, so in other words, we're saying that x take pi on 3 is equal to 0, in which case x is simply equal to pi over 3. So when x equals to pi over 3, that's when we start. Okay, and that makes a lot of sense just looking at the equation, because the presence of this minus pi on 3 would represent a horizontal translation by pi on 3 units to the right. Okay, this is what the minus pi on 3 represents. So it's very telling that x also equals to pi on 3. And pi on 3 would be situated roughly over here. Okay, so now that we have our starting point, we know that we have to keep going. We repeat ourselves at this point here. First off, we start over here, not at the x-axis. We repeat ourselves every 2 pi radians. So let us first add pi on 2 to pi on 3 a bunch of times. And another way of adding pi on 2 to pi on 3 is by simply doing plus 3 pi on 6. So if we add pi on 2 to pi on 3, that's the same as 5 pi on 6. And 5 pi on 6 is roughly over here. And then 5 pi on 6 plus 5 pi on 6 plus 3 pi on 6. That would be the same as 8 pi on 6, which is the same as 4 pi on 3. And 4 pi on 3 is 240 degrees, so that would be roughly over here. Now 8 pi on 6 plus 3 pi on 6, that's 11 pi on 6. 11 pi on 6 is roughly over here. Also, this should say 7 pi over 4, not 7 pi over 6. Okay, roughly over there. And then we can keep going one more. If we do 11 pi on 6 plus 3 pi on 6, that's the same as 14 pi on 6. And 14 pi on 6 is really just the same as 7 pi over 3. And that would be roughly situated over here. It's off our axis, okay, but it's roughly over here. Okay, so now that we have these points here, now that we have these points on our x-axis, let us now actually work out where to plot these points. So I'm going to also draw vertical lines just to make our life simple. Okay, so when we look at the sine graph, we know that normally we would go up, then down, so up, then down, then down, then up like this. However, for this equation, we know that the amplitude is actually negative. So rather than starting at our mean line and going up over here to -1, we would actually start here and go down first. Okay, it's a reflection across the x-axis. Well, in this case, a reflection across this mean line. So let us now graph this out properly. Okay, we would go from this point to the min line. It's a little bit of a tongue twister. To the min line, back up to the mean line, then to the max line, back down to the mean line. Like such. Okay, and if I get rid of all of my vertical and horizontal lines, the graph would end up looking like this. And verify it on your scientific or your graphing calculator or on Desmos, and you will see this is the graph that you get. And this is just for one period, so you can continue doing the graph a bunch more times, either to the left or to the right. And that is how you graph y equals to minus sine x minus pi on 3 take 2. Okay, and the last graph for the day is 3 cos of half pi x minus 1. Again, let's speed run this. let's work out the important information. The amplitude is equal to 3. The period is equal to 2 pi divided by the coefficient of x, which is half pi. So 2 pi divide half pi. So the pi and pi cancel, and then 2 divided half is the same as 4. So our period is simply equal to 4. Our max line is equal to d plus a. In this case, d is equal to 0. Okay, so max line is just 3. And then our mean line is equal to the value of d, which is a 0. And the min line is equal to 0 take 3, which is equal to minus 3. So now that we have these 5 pieces of information, let us now graph our lines. So we can see that we have 3 as our maximum. Then we have 0 as our mean. And then we have minus 3 as our minimum. Nice. Now let us work out whether cosine starts at the min, max, or the mean. Normally cosine will start at the maximum, and it would only start at the minimum if we have a negative in front of our amplitude. And because we don't, we know that we start at the maximum for this graph. So I'm going to plot a point, right, somewhere on the maximum line here. But how do I know where I start on the maximum? Well, let us either do one of two things. We can solve the equation, or we can use transformations. For this question, I'll just solve the equation for when y equals to 3. So if we solve this equation for when y equals to 3, 3 equals to cosine of half pi x minus 1. Then we can say that, 3, I forgot to 3. We can divide both sides by 3 to get that 1 equals to cosine of half pi x take 1. And we know that the cosine of 0 degrees is equal to 1. So we can say that the half pi x take 1 is equal to 0, in which case half pi x equals to 1. And then we can say x would be simply equal to 2 divided by pi. And if you're wondering what the value of 2 divided by pi is, it's roughly equal to 0.64. Roughly 0.64. Okay, so now let us draw where we have 0.64. 0.64 will be roughly over here. Nice. So now we have that our period is equal to 4, but our period divided by 4 equals to 1. So we keep adding 1, 0.64. We keep adding 1 to this value, and that's how we know when to go down to our mean line and then down to our min line. So 1 plus 0.64, that makes it easy for us. It's 1.64. Then 1.64 plus 1 is 2.64. Then 2.64 plus 1 is 3.64. And then 3.64 plus 1 is 4.64, which is off our graph, so I'll just put that point over here. Okay, so now we can just connect the points. Okay, we can connect the points by going from maximum to the mean, then mean to the minimum, then minimum to the mean, then mean to the maximum. Okay, and this is, if I had proper graphs, I would draw it a bit nicer, but this is how you draw sine and cosine graphs. You need these 5 pieces of information plus the period divided by 4, and you can draw one period of any graph of sine and cos that you want.